Now let us discuss a little more about 8051 serial port communication. The contents of today's discussions are given here. The first point is RS-232 standard. So here we'll be discussing something about RS-232 standard, how exactly it works, everything related to that. The second point is DB9P Connector. Here mainly we'll be studying about the structure and mainly the functionalities of each pin of DB9P connector. The next topic is DB9P connector. Here also again mainly the functionalities of each 9 pins of DB9P connector. The next topic is data transmission and reception using RS-232C. Mainly how exactly the data transmission and reception takes place using RS-232C, and the flow chart showing handshaking process. The next topic is RS-232 standard. Now here let us have the introduction to RS-232 standard. In response to the need for signal and handshake standard between DTE, that is data terminal equipment, and DCE, that is data communication equipment, the Electronic Industries Association, that is EIA, introduced EIA standard, that is RS-232, in the year 1962. It was revised and named as RS-232C in the year 1969 by EIA itself. It is widely accepted for single-ended data transmission, that is one-to-one data transmission over short distance, that is for very short distance communication with low data rates. Modems and other equipments used to send serial data over long distances are known as data communication equipments, that is DCR. The terminals and others computers that are sending or receiving the serial data are referred to as data terminal equipment, that is DTE. This standard describes the functions of 25 signal and handshake pins for 25 pins and handshake signals for serial data transfer. It also describes the voltage levels, impedance level, rise and fall times, maximum bit rate, and maximum capacitance for these signal lines. RS-232C specifies 25 signal pins, and it specifies that the DTE connector should be male and the DCE connector should be female. So this is very important thing here. And what they are telling here is the most commonly used connector should be female. So that means the most commonly used connector is DCE. So it should be a female type. The most commonly used connector, that is DB9P, is shown in the figure. The figure mainly shows the 25 pins of DB9P connector and the signals associated with it. Now as shown in the figure, the pin number 1 is protective ground, and pin number 2 is transmitted data represented as TXD, and its direction is towards DCE. So what we can say is the signal direction on DEC is in. So the third pin is received data represented as RXD, and it is directed towards DTE. So what we can say is the signal direction on DEC is out. So similarly, pin number 4 is request to send, that is RTS, direction is towards DCE, and pin number 5 is cleared to send, so represented as CTS, direction is towards DTE, and the sixth pin is data set ready, represented as DSR, direction is towards DTE, and pin number 7 is signal ground. Pin number 8 is received line signal detector. Pin number 9 and 10 are reserved for data set testing, mainly for testing purpose. Pin number 9 and 10 are used. Pin number 11 is unassigned, used for future operations. And pin number 12 is secondary received line signal detector. 13 is secondary clear to send, 14 is secondary transmitted data, pin number 15 is transmission signal element timing, that is DCE source, and pin number 16 is secondary received data, pin number 17 is receiver signal element timing, that is DCE source again, and pin number 18 is unassigned, pin number 19 is secondary request to send, pin number 20 is DCE, that is data terminal ready, uh, DTR, and pin number 21 is signal quality detector, and the pin number 22 is ring indicator, 23 is data signal rate selector, and pin number 24 is transmit signal element timing, that is DTE source, and pin number 25 is unassigned. The table here shows the pins and signals description for RS232C, that is DB9P connector. The first column of the table mainly represents the pin number, and the second column shows the common name of each pin, and the third column represents the RS232C name of each pin, and the fourth column gives the description of each pin, and the fifth column shows or gives the signal direction on DEC. As shown in the table, the RS232C name of first pin is AA, and it is protective ground, and the common name of the second pin is TXD, and its RS232C name is BA, and it is transmitted data, and the signal direction on DEC for this particular pin is in. And the third pin, if you consider, the common name of the third pin is RXD, and RS232C name of the third pin is BB, and it is received data, and the signal direction on DEC is out. Similarly, like that, the table gives the common name, the RS232C name, the description, the signal direction on DEC of all the 25 pins of RS232C DB9P connector. And one more important thing what we can observe in the table is pin number 11, pin number 18 and pin number 25 are unused or unassigned, and mainly it is given for future use, and pin number 9 and 10 are reserved for data set testing. The next topic is DB9P connector. Since all the pins are not used in PC cable, IBM introduced the DB9P version of the serial I/O standard, and that is shown in the figure. It uses only 9 pins where the DB25P connector uses 25 pins. The pins of DB9P connector is shown in the table. As shown in the table, the first pin of DB9P connector is DCD bar. It is data carrier detector pin, and it is active low in nature. The second pin is RXD, that is received data. And the third pin of DB9P connector is TXD, that is its description is transmitted data. And the fourth pin is DTR, that is data terminal ready. And the fifth pin is GND, that is signal ground. And the sixth pin is DSR bar, that is data set ready. This is also active low in nature. And pin number 7 of DB9P connector is RTS, that is request to send. And pin number 8 is CTS, that is clear to send. And pin number 9 of DB9P connector is RI, that is ring indicator. And the very important thing we can consider here with respect to DB9P connector when we compare it with the DB25P connector is The total number of pins are minimized here in DB9P connector. The next topic is data transmission and reception using RS-232C. The figure shows the digital data transmission using modems and standard telephone lines. As we discussed earlier, modems and other equipment used to send serial data over long distances are known as data communication equipment, that is DCE. The terminals and computers that are sending or receiving the serial data are referred to as data terminal equipments, that is DTE. Now let us discuss about the process of digital data transmission using modems and standard telephone lines. After the terminal power is turned on and the terminal runs any self checks, it asserts the data terminal ready DTR bar signal to tell the modem it is ready. When modem is ready to transmit or receive data, it asserts the data set ready, that is DTR bar signal to the terminal. This is the first process. After receiving DTR bar, the DTE requests use of the data channel by asserting RTS bar signal to begin transmission. The modem at the receiving end is then dialed. This answer mode modem responds with a 2225 Hz carrier frequency. When the modem connected to the sending terminal receives this carrier, it asserts carrier detect, that is CD bar signal to the terminal. After proper time interval, the modem sends clear to send signal, that is CTS bar, indicating modem and communication channels are ready for transmission. Immediately after CTS bar signal, the terminal at the transmitting end sends the serial data on its TXD output. A similar handshake takes place for receiving data also, and this process is explained in the figure. As shown in the figure, a microcomputer control terminal that represents DTE, that is data terminal equipment, and the modems, they represents DCE or data communication equipment. And DTE to DCE communication, that is they are connected through RS-232C connector here, and the different modems are connected through telephone lines. So that is what is represented here in this particular diagram. This figure is a flow chart showing handshaking process for data transmission and reception using RS-232C connector. Next, the first step is to check whether the DTE, that is data terminal equipment, is ready or not. So for that we should check the DTR signal of DTE. So if DTR is low, yeah, then DTE is ready because it is an active low signal. So after that, the next step is to check if the modem is ready. So here also for that what we need to do is read DSR signal from the modem. So this is also active low signal. If the DSR signal is low, yeah, then the modem is ready. If not, yeah, we should again wait for the modem to get ready. Now if the DSR signal is low, that means the modem is ready. Then the next step is to initialize pointers and counters for the text to be transmitted. So that is nothing but prepare for transmission. So after that, the next step is the DTE request use of the data channel to begin transmission. So that means for that the RTS signal should be low. After that, make sure the modem has made contact with the remote modem. So to check this, what we need to do is we should read the CD signal from the modem, and the requirement is it should be low. If it is low, the meaning is yeah, it has made this one what it has made the contact with the remote modem. or else, yeah, we should wait for the this operation to continue. Yeah, that means we should wait for CD bar signal to become low. Now, if CD bar signal is low, that means the remote clear is detected. So in that case, the next step is check whether CTS bar or CTS signal is low. So that means when CTS bar that goes low, the modem and the communication channel are ready for transmission. So for the next transmission process, CTS signal that should go low. So if no, what happens is, again we should wait for CTS signal to go low. If the CTS signal is low, that means the clear to send. So that means the modem is ready for transmission, and wait for the modem to be ready, and after that the transmission process begins. And the important thing is, these are the handshaking signals to begin the transmission of data. And the important thing is, a similar handshake signaling takes place during reception of data also. One important thing we need to remember is, the serial port of 8051 is full duplex. That means it can transmit the data and receive the data, and it can receive the data simultaneously. Means simultaneously it can transmit and receive data. So the important thing we need to understand here from this flow chart is that the series of handshaking process, that means the series of the handshaking process what we have studied now, that takes place in RS-232C during transmission of data and also during reception of data.